everybody, I'm Miss Cooksey. Today we're going to be talking about quadratic functions in the vertex form. This video is going to be so similar to the video previously. So if you haven't watched that one, make sure you go back and watch it so you know how absolute value functions work so we can apply it to quadratics. So we're starting with the parent function. The parent function for a quadratic is x squared. We could also write this, if we wanted to write the long way, as 1x squared plus 0x plus 0, ax squared plus bx plus c. But we know when we multiply times 0, it equals 0, and when we add 0, it stays the same. So we can simplify this to just be x squared. So our parent function is f of x equals x squared. So let's go ahead and see what that looks like. I'm going to start with 0, 0. So when I substitute in 0 for x, 0 squared is 0. When I substitute in negative 1 for x, negative 1 squared is positive 1. Same with 1. 1 squared is 1. So let me go ahead and quickly graph those points so we can see them on our graph. We've got 0, 0, negative 1, 1, and 1, 1. This is the exact same as our absolute value functions, but we are going to add a little bit more. We're going to look at negative 2 and positive 2. When we square these numbers, we get 4. So this is where it's a little bit different. This is why we don't have a nice straight line like with those absolute value functions. It's going to start a curve. So this is our parent function. Vertex form tells us how we're going to shift from our parent function. The rules for a quadratic and for absolute value are the exact same. Let's review them. With a quadratic, if this a value is the absolute value is bigger than 1, it's a stretch. If this a value is between 0 and 1, it's a compression. It gets flatter. So as a quick reminder, a stretch would make it really nice and narrow, a nice narrow U. And a compression would make it a nice wide parabola. If a is negative, it's a vertical reflection and it is going to flip upside down. Again, just like absolute value functions, we are going to, that h and k value is going to be our vertex. H tells us the x coordinate, k tells us the y coordinate. H is going to tell us the horizontal shift, k tells us the vertical shift. And we need to change the sign of h. Let's apply this the exact same way we applied absolute value functions. So here I got x minus 2 squared minus 4. The vertex is h and k, so 2 and 4. We have to change the sign of the x value, so positive 2. We don't change the sign of the y value, so negative 4. There is no a value here to change our transformation. So our transformation is going to be right 2 units, down 4 units. And this is what it looks like. We're taking that parent function and we're shifting it right 2 units and down 4. And here it is. Next, we have f of x equals negative 2 times x minus 1 squared plus 1. Starting with that vertex. Our vertex is again h and k. We have to change the sign of h. So we have positive 1, positive 1. This time, we do have an a value that's going to have some transformation. A here is both negative and it's 2. So it's going to be a stretch and reflected vertically. So it's going to get narrower and flip upside down. Our vertex tells us our side to side and up and down transformation. So it's going to be up 1 unit, right 1 unit, and it's going to look like this. So we took our parent function, which was here. We made it narrower, we reflected it vertically, and we went up 1 unit, right 1 unit. Here's our last example. Negative x plus 3 squared. There's a invisible plus 0 here that we're going to remember. So our vertex is going to be negative 3, 0. We always change the sign of h. Our transformation, this minus sign, tells us we're going to reflect it vertically. We're going to flip it upside down. Our vertex tells us that we're going to move left 3 units, but we're not going to change in the y direction because we have plus 0. So we shift it upside down, move left 3 units, and this is what we've got. Thanks for watching this video. I hope it was helpful. Make sure you subscribe so you never miss a video, and I'll see you next time.